Hello, and thank you for stopping by my poster. My name is Martin Constant, and I'm a PhD student at the Ludwig Maximilian University of Munich. My current research investigates the role of saliency for visual working memory in complex visual scenes. For more information about this project, you can scan the QR code on the right. My poster has 4 major points. Firstly, saliency enhances visual working memory performance, with salient items being recalled more precisely than non-salient items. Secondly, this effect scales with the saliency of items. The more salient an item, the better it is recalled, especially when it's among less salient items. Thirdly, increasing the encoding time decreases but does not fully erase the effect of saliency. And finally, in the right conditions, the effect of saliency can be counteracted by top-down control. Before going any further, allow me to quickly explain why we felt that this research was necessary. The visual search literature tells us that salient targets are found and processed faster than non-salient targets. We also know that the orientation of the target with regard to the background can make it salient. The problem lies in the fact that visual working memory studies often ignore saliency. In the traditional displays, targets are often highly salient. But what about more complex displays? Are studies using cues that are, due to their uniqueness in the display, salient themselves? All of this has not yet been evaluated in the visual working memory framework, and that's what we attempted to do here. For this short tour, I will skip the abstract and dive right into the methods. We used a continuous recall paradigm. Participants had to recall the colors of the targets by clicking on a color wheel. 4 of the 5 experiments, target saliency was scaled by tilting them. In the remaining experiment, it was determined by the eccentricity of the target. I will give more information on the experimental design in a minute. Analyze the absolute angular distance between the color of the target and the color chosen by the participant on the color wheel. Therefore, the maximum error was 180 degrees and chance level was at 90 degrees. We also use sequential bias factor testing for determining sample sizes. It means that we pre-registered a hypothesis with a bias factor threshold. Once this threshold was reached for all the hypotheses of an experiment, data collection was stopped. As promised, I will now explain the experimental design. Most experiments are very similar to the first one, so I will start with this one. We have an array of 33 vertical bars, organized into 3 rings. On the middle ring, 3 bars are tilted. These are the targets. One bar is tilted 12 degrees, the second is 28 degree tilted, and the last one is 45 degree tilted. It's important to note that all targets shared the same relevance, so it was not beneficial to encode one more than the others. This display was presented for 350 milliseconds. Response display was composed of placeholders for the bars. Participants had to recall the color of the filled placeholder. We used placeholders to lower the risk of swap errors. For the second experiment, we had 2 types of displays. Mixed displays are identical in every point to experiment 1 displays. Same displays, however, were different in that all targets shared the same saliency. So here, for instance, they were all 28 degree tilted. The third experiment, there were only 3 squares, and they were all targets. 1 square was placed at 2 degree eccentricity, 1 at 4 degree, and 1 at 6 degree. The fourth experiment used again the same displays as experiment 1. The difference was that instead of a fixed 350 milliseconds presentation time, we used 7 different times, 14 milliseconds to 2 seconds. For the last experiment, displays were identical to experiment 1. Here we used 3 presentation times from 350 milliseconds to 3 seconds. The main difference lies in the fact that we changed the relevance of the target. The least tilted bar was probed on half of the trials, the 28 degree bar was probed on 2/6 of the trial, and the most tilted was probed on the remaining 6. Participants were made aware of this distribution. So what did we find? I will only go over the graphs here, but if you're interested, I encourage you to come ask questions during the scheduled Zoom conference. On all graphs, the orange indicates low saliency targets, the blue indicates medium saliency, and the green indicates high saliency. For experiment 1, you can see that recall error decreases with the target saliency. It is less obvious for experiment 3, but the effect is there nonetheless. For experiment 2, for the mixed displays on the left here, the effect of saliency was replicated, and it was also present for the same displays on the right here. For experiment 4, performance increased with encoding time, and the effect of saliency decreased, but was not fully erased. Finally, in experiment 5, at 350 milliseconds, the manipulation of relevance did not change the saliency effect. However, at 2 and 3 seconds, the effect of saliency was counteracted by the top-down relevance effect. If you want more information, don't hesitate to contact me. Thank you for listening to me, and enjoy the rest of the conference.